have weighted graphs, networks, and shortest paths. This is lesson 8 within our networks. Okay, here's objectives. Weighted graph, again, definitions, you need to know these. Right, shortest path, it's kind of a bit of a new topic that we'll look at. Right, interpret a network and find the shortest path via inspections. We'll talk about that in a second. It's quite a process. Right, weighted graphs. Basically, within a weighted graph, all right, six towns are connected via road. All right, town represented by the vertices of each of the graphs. The road between the towns are represented by the edges, etc. Now, what we're going to do is, if we give more information regarding this, is that if we add numbers to each of the edges, that might represent how long it takes to go between each of the towns, or a distance, or something along those lines. And by doing so, it creates it in being a weighted graph. So weighted means basically you have numbers allocated to all of the edges. All right. So the first one would be unweighted, and our second one would be weighted. All right, and this time we're talking about the distance between towns in kilometres. Okay, so network is a weighted graph that represents a real life situation. In this case, we said distance between different places. All right, etc. Here's our first example. Network opposite is used to model the tracks in a forest connecting the suspended bridge B, a waterfall W, and a large tree of bed thick ferns. All right, allocating each of the vertices to a letter. Walkers can enter and leave the forest through either gate 1 or gate 2. So we have either gate 1 or we have gate 2 there. The number of edges represents the time in minutes taken to walk directly between these places. 10 minutes, 9 minutes, 8 minutes, etc. How long does it take to walk from the bridge directly to the fern? Okay, so the bridge would be represented as B. Okay, directly to the ferns. Okay, the ferns, which would in fact be F. All right, nice easy question to start off with. What is that allocation there? It is 12 minutes. How long does it take to walk from the tree to the ferns via the waterfall and the bridge? Okay, so you create a bit of a path for yourself, starting at the tree, etc., effectively, to the ferns, which is obviously all the way at the top, via the waterfall and the bridge. So that means we are restricted in following that path there. Adding them all together and you end up with 31 minutes. Nice easy question. Nothing too tricky at this point. Weighted graphs and networks. Okay, back to this example. All right. What about if we wanted to think about, or what is the shortest path between the certain towns? Okay. Right, so if they're directly connected via a road, right, it may not in fact be obvious, okay, considering some of the different towns and allocations to those towns. All right, so don't think just because one of the lines is longer, it is in fact allocated to a longer time. So just be a little bit careful of that. So find the shortest route between towns C and F in the network shown. So we want to go from town C, okay, all the way to town F. So we want to find the shortest way to do this. Right, so one of the possible ways is list out the paths that you could in fact get there. Here's one. Answer for that is 16 k's. All right. Here's another one. Answer for that is 18 kilometers by adding those distances together. Here is another one. Answer for that, 20 kilometers. So we could in fact do quite a few more for this as well. If we did other ones, we could in fact say, okay, what about if we went this way? We went there, down to here, and up to there. So in other words, we went C, B, D, E, and F, all right, which is going to be 5 plus 5 plus 9 plus 7, 16. So that's 26. Now, it's obviously not that one because it's significantly more. So we've got to maybe come up with a slightly better method than just listing every single path to go from C to F. All right, so we've got to come up with a better option of doing this. So we had this one here at 16 kilometres, as we said before. We had this one at 18. We had this one at 20. Right, and we just did that. Okay. Working out is required. So, back to our example from before. All right, we had this one just before, the shortest path from this to this. Okay,